What is domain modeling? Hello, my name is Eric Normand, and this is my podcast. Welcome. So, today I am starting to record these explorations about domain modeling. About 2.5 years ago, I started podcasting about the ideas I was exploring for functional programming, which eventually turned into Grokking Simplicity. I didn't have a podcast before that. If you go back to the very, very early episodes, you'll see that it's me rehashing these ideas, trying to define them, trying to figure out ways of explaining them. And that eventually led to Grokking Simplicity, which is all about functional programming. And one thing that happened in the development of Grokking Simplicity was that I had a plan for 3 parts. The table of contents had 3 parts. The first part was all about actions, calculations, and data. Very fundamental skill. And once you've incorporated that, you've internalized that, then you can move on to the next level of thinking in functional programming, functional thinking, if you will, which is higher order abstractions, higher order functions, functions as arguments, stuff like that. And that leads to stuff like map, filter, and reduce, and building your own concurrency primitives and things like that. And then the third part was another leap, which is that once you've started doing stuff in calculations for enough time, calculations and data, you start to, if you go through the door, not everyone does this, it's kind of a more advanced technique, but you can start to think about your program much more abstractly. You start to think more algebraically. And I have a whole episode on that if you want to search for algebraic thinking. And so that was what the third part was going to be about, this algebraic thinking. Basically, thinking about your program and thinking about what the code, what you can know about the code without running it, right? That there's a lot that can be understood abstractly and working with that. So that got cut. The reason it got cut was a good reason. I was already mostly done with parts 1 and 2, and I was thinking about cutting it into 3 volumes. But talking with the publisher, they were skeptical that 3 volumes was the right way to do it. They proposed the first 2 go together and the third one is separate. And the reason was that the first 2 form an arc from beginning, like no knowledge of functional programming, all the way to professional. If you follow through and you learn all the skills in there, you have everything you need to be a professional functional programmer. Meaning you get paid to write in Haskell or Clojure or whatever. And this is empirically true. Not specifically the book itself, but these are the ideas that I took from people I knew, and I talked with them, I observed what skills they had, and I put all the most important ideas in the book. So if there was an idea that was and those happen to be in the first 2 parts, right? So all that is to say that in theory, if you're already a programmer, you already know how to program, this will get you from no knowledge of functional programming to you can call yourself a professional functional programmer. The third part was something that I think is very important, and I do think it's the next step, but not everybody gets there. Or maybe they get there, but they don't need to get there to start getting paid, right? So that suggests a different audience, and that so like in a maybe a senior person, and it suggests a different book. Cut it there. And that was also convenient. It was pragmatic because then I could be done sooner because I was almost done with part 2 and the book could be released. And then I wouldn't have to think about part 3 until all that was done. Okay, so that's what we did. And the book came out in April, and now it is the end of October. Yes, the end of October, and I have recently resurrected the idea. I went through my notes. I've been jotting stuff down, trying to organize the ideas and the definitions. I'm talking about it in my newsletter now, so I'm talking about it here and in the newsletter. And I'm not ready yet to say it's going to be a book, but I imagine it will. I'm not committing to it yet. I'm waiting for the ideas to really crystallize into something I think is worthwhile. And I will know somehow, intuitively, that the idea is big enough, or maybe I'll never know, right? It's possible that I won't know, but I won't make it a book until I know that I will have the motivation to finish it, right? That I know that this idea is big enough and well-defined enough to turn it into a book. Because it's a lot of work. But I'm perfectly willing to make a podcast episode talking about the ideas, and I'll probably do more than one. So in this first one, I would like to simply define domain modeling. Again, this is one of those things that might help me more than it helps the reader. But I think a good definition can kind of help you with the scope and help you pin down the idea more precisely. And so that's what I'm trying to do. Now I've searched like, what is domain modeling? And you get a lot of articles. There's a lot of articles about domain modeling, but none of them actually define it. So you kind of get an idea of like maybe a process or what one might kind of look like. And I want to be more precise. So to me, my definition right now, it's evolving, right? Like even last week I changed it completely. But a domain model has 3 things. It encodes information. It encodes operations on that information. So the information is relevant. So relevant information. It encodes, let me start over. 3 things. 1, it encodes relevant information. 2, it encodes operations, domain operations on that relevant information. And 3, it defines invariants, the stuff that has to be true, regardless of what operations you do or where your data comes from and stuff like that. So if you have those three things, you have a domain model. And of course, that doesn't tell you much. It just tells you whether you have one or not. It doesn't tell you whether it's a good one or how to make one and how to make a good one. So that is what the book is going to be about. To me, the real benefits of domain modeling are all the benefits that are traditionally associated with software design, as it's called. But I find software design often puts the cart before the horse. Okay, well, I wasn't planning on going here, but I will. I think this is an important topic. The software design, when it is defined at all and its goals are defined, will say something like the point of software design is to decrease the cost of maintaining or writing software, right? And so it's a very sort of cost-centric, business-centric goal. And that's great. It makes it good for convincing business that we do need to invest in software design, because then future changes to the software will be easier, right? And that's cool. But because the focus is on the cost is kind of a lagging indicator. Like, you don't really know how much it's going to cost until you do it, and then you can say, well, it took me 10 hours. You can estimate, and there are kind of rules of thumb for that are not proven, but pretty good indicators of if you move this leading metric in one direction, it makes the cost go down. So, for instance, it's pretty clear that good names of functions help you understand what you're reading, the code, like what it does. And so that helps you figure out where a bug is, for instance, or if you need to change something, it can make it clearer what needs to change. So software design seems to have discovered a bunch of these leading indicators that help this lagging indicator of cost of maintenance. So the leading indicators that people will cite are things like good names, the length of methods, code organization, the classes, and whether they are coupled and coherent, right? There's all these leading indicators that clearly help move the cost down, which is a lagging indicator. And that's good. I mean, I think that's it's fine. It's fine for what it is. But I find that the problem, the thing that's overlooked, let's say, is that this is all focused on the code. Size of your method, the name of your function, what file a function is in, how your code is organized on the disk. It's all about your code. And that forgets that your code has to model in some way the real world. That your code, a person class is capturing some information about a person, and that actually has to correspond to like the stuff that a person can know about themselves, right? that kind of thing is taken for granted. It is simply taken as, well, this is the class, now let's move stuff around, move it to this class, make a new method that calls this other thing. Like, it's totally forgetting that there is a world out there and that your software has to model it. I mean, some small part of it, some small part of the world, what we're calling the domain, and then there's relevant information for that domain. And if there's one insight that that I want to base the book around, it's that we can't lose sight of the importance of keeping a tight fit between the domain, the actual real world thing we're modeling, and what our code represents, if in quotes, how it understands that domain. If there's not a tight fit, that is the biggest contributor to bugs, to poor understanding, to slowness of developing features, slowness of changing a feature if the requirements change. Again, all that stuff, that slowness, that cost, that is all a lagging indicator. And I want to find leading indicators that are not about the code, but about the relationship between the world and the code. Okay, not just the code itself and is it pretty, but what is the relationship between the real world and your code? And those boom, boom, boom dominoes lead to the lagging indicator of cost. And I think that that fit between the domain and the model as expressed in your code, is overwhelms, code quality, the cleanliness of your code. That if you have a hugely nested if statement, it's probably because your model is not very good. Not because you're messy and you haven't cleaned your room. It's just your model isn't good. And so I want to make a book about that. I mean, I'm not saying I will, but that's the idea that is central to the book, to the top, as the way I want to approach this topic. So the book will talk about how to explore a domain, figuring out all the relevant information, the domain operations that you'll need, how those relate to the relevant information and constrain the design of it, and then the invariants and how those constrain the design, and how to encode those, because I think part of the definition that I missed is that these three things are typically encoded in a programming language, or maybe more than one programming language, because you have systems that have they'll have SQL and a backend language like Scala and maybe another query language they have to work with, and then maybe their tests are written in something else. The way we break up systems today is usually multi-language, but it's all of it's written down in programming languages, or it's not, and it's in our head, or it's in the spec. So we need to encode it somehow in English, in our spec, or in a table, or in our code, etc. So I think that's good. That's what the book is going to be about. Domain modeling, what it is, the process, how to make it good, how to make it lead to this decreased cost and maintenance, because I think that is a good metric. But if you don't have a good domain model, you're gonna reduce the ability to be to be flexible and change your requirements and things like that. Another thing that I believe a good domain model can be a competitive advantage. So it's not just like, oh, we're reducing the cost of carrying software and modifying the software. But it could actually like open up new markets and just have fewer bugs, and it's do magic for the user. And I want to explore that too. So, well, see you in the next episode. My name is Eric Normand, and I've been exploring domain modeling today. And please subscribe. As always, rock on.